Hi students, welcome to my channel. In today's session, I am going to discuss displacement, double displacement, oxidation and reduction reaction students. Definition. See here, this is very important key points. Whatever I am telling, it is key points students. More reactive element or metal displaces less reactive element or metal. This is very important key point definition for this reaction students. Or metal. Here which is the key point means this word students, more reactive element displaces less reactive element. It is a key point students. Without that no one will give marks. So here example as well as representation I am giving here. What is the general representation for this reaction? See here, AB is one compound. When it's react with one element or metal means what happens? It gives one new product, that is CB plus A. Why it is CB not BC means here one important concept is there students. See here, this is cation, this is anion. See this splits as plus, here minus. This is an element. Mostly it forms plus. It is an element but it forms plus charge. Okay students, when it combines what happens? This is plus, this is minus and this is an element. Clear students? So it is a metal. Metal always forms positive charge. Clear students? That's why first you have to mention positive charge, then negative charge. That's why it is CB, not BC. You should think about that. You should not write as BC. It is a wrong students. Only CB is correct. Clear students? Okay. Now example for these reactions. See, first one. These are very important example students. See, first example. Iron nail reacts or dipped in copper sulfate solution. What happens? Here, that nothing but this C is going to reacts with SO4. See students, this is C. With example I am comparing C. This is C, this is AB compound. Then what is the product? CB. Here which is C? This is C, right? So Fe, and which is B? SO4. So FeSO4 and A is separated, Cu. Clear students? So here color of iron nail, it is brown color, right? It is nearly brown. When brown color iron nail dipped in copper sulfate, the color of copper sulfate is blue color students. Okay, so this solution, when iron nail displaced or put in blue color solution of copper sulfate, after some time the solution changes into light green students. So this light green color solution indicates the copper is displaced by iron. So now the solution becomes iron sulfate and copper is displaced. Clear students? Copper deposited on that iron nail. It is very important reaction students. With the color you should mention. Whenever you are writing this equation, mention the color. Okay, here one question will arise. Why this iron displaces copper? Displacement is nothing but changing the place. Here everything based on the series students. These are metals. So here one reactivity series are there. Based on the reactivity series only reactions will undergo. Not all the metals undergo this type of reactions. That reactivity series is, see, generally reactivity series or metal series we will tell. Reactivity series or metal series. Okay, in that series, in order only they arrange. Okay, so first sodium metal. Sodium metal is the most reactive metal. Sodium, before that potassium. So potassium is more reactive than sodium. Sodium is more reactive than calcium, then magnesium, then aluminium, then zinc, then iron, then tin, lead. After that hydrogen will come, students. Hydrogen is considered as a standard. Hydrogen, then copper, mercury, silver, gold. This is the reactivity, students. Based on that only displacement reactions will undergo. See here, compare iron and copper place. So comparing with copper, iron comes first. That means more reactive metal. So only more reactive metal only displaces less reactive. Clear, students? If copper is there, means this reaction will not occur. Copper will not displace iron because it is less reactive. Clear, students? Like that. See here, if you compare aluminium and copper. So copper sulfate solution is there, aluminium is there, means aluminium sulfate will form. Clear? So more reactive metal. These are more reactive metals. Before hydrogen are more reactive metal. Before hydrogen, more reactive. In this series, before hydrogen are more reactive. It is very point, students. You should know this series. Without that you can't answer for the questions from this displacement reactions. Then after hydrogen are less reactive. So be thorough in this reactivity series. From this many types of examples they may give. So next we will discuss some other examples. See here, second example. If zinc plus copper sulfate is there, it what forms? Compare the metal places. See here, zinc is a metal, copper is a metal. In series you have to check. See here, before copper zinc comes, so zinc is more reactive, right? So mention the state also. Zinc is a metal, so solid. This is aqueous form. Clear, students? In product also one aqueous solution and plus one solid will form. So see here, so zinc is more reactive metal, that's why it forms zinc sulfate plus copper. Clear, students? So it displaces copper. Here it is aqueous solution. This is a compound. So compound soluble in the solution and this is solid. Clear, students? So in this reaction what you observe? So which is more reactive metal? Zinc is more reactive than copper. This one you should write, students. It is very important key point. Clear? And one more example. Next, lead dipped in copper chloride. Here state lead in solid form. This is aqueous solution. Without that they will not provide marks. You should mention the state of the compound. So what happens? See, check the priority here. Lead, before hydrogen lead is there, so it is a reactive metal. After hydrogen copper comes. So now what happens? Now this lead reacts with the chlorine and displaces copper. So here PbCl2 plus Cu. Clear, students? Now here state, it is aqueous solution, and here it is solid form. So now what is the point here, students? Lead is more reactive than copper. Pb is more reactive than copper. Okay, students. And next example. So these examples are very, very important examples. Next, magnesium reacts with copper sulfate. It gives what? Here magnesium is a metal. So metal in the form of solid state, right? So here it is solid form. It is aqueous solution form. What happens? See the reactivity, students. See here, where is magnesium? It comes before hydrogen, it comes. So it is a reactive metal. Copper after hydrogen, so less reactive metal. So what happens? This magnesium displaces the place of copper in solution. So what is the product? It is MgSO4 plus Cu. Okay, students, only more reactive element displaces less reactive element. Now it is in solution, so aqueous, it is displaced solid. Okay, students, here what is the point? Magnesium is more reactive metal. You should not write like this, more reactive than which metal, that one you should represent, than copper. Okay, because you should not tell only magnesium is more reactive. Many metals are there. Comparing with one another, it is more reactive. So comparing with copper, it is more reactive. Or comparing with mercury, or comparing with silver, gold, it is more reactive. Okay, students. Okay, next. One more example. So these are very, very important examples. Next, copper plus AgNO3 gives what? Okay, students. See here. So copper is a metal, so solid state. It is a compound dissolved in water, so aqueous state. Now here metal you should check. Copper is a metal, silver is a metal. So you should check the position in reactivity series, where this copper comes here and where silver comes here. See now, copper and silver. See students, copper here, silver here. Which one comes first? Copper. That means more reactive. Which one comes first? It is more reactive. Copper comes first, more reactive than silver, or more reactive than gold. So now what is the product? CuNO3 twice plus silver. Clear, students? To balance this, 2 silver. Clear? Now this is aqueous solution and this is solid. Clear, students? Here what is the point? So copper is more reactive than silver. Okay, students. So these are examples for displacement reactions. Please go through these examples. It is very, very important. So one more thing, you should mention the color also. For copper sulfate, blue color, it converts into white color. Like that, mainly for this reaction, students, Fe plus copper sulfate. For this reaction, mainly mention the color of the solution. Clear, students? So it is very, very point regarding this displacement reactions. Many questions they may ask from this displacement reaction, students. It is clear. I hope you are clear in displacement reactions. Okay. Next, I am giving some other examples, students. Find out whether the reaction happens or not. See here. Examples. See now. Copper sulfate plus iron. Will you get product or not? Okay. Whether this reaction happens or not. Find out. Next. copper sulfate plus zinc and copper chloride plus lead chloride plus copper. For this, whether the reaction happens or not, find out, students. I am giving time to find out this answer for these reactions. So for finding the answers, you should recall the reactivity series. Then only you can understand the concept. So this alone metal should be more reactive than another one. So here these reactions are possible reactions, right? Iron is more reactive than copper, zinc is more reactive than this one. Okay, so this reaction takes place. So this reaction happens, but see students, compare here and here, copper and lead. See here, these are metals, right? This alone metal should be more reactive, not compound metal. Then only the reaction happens. It is the concept, students. Alone metal, that is free metal. What is the concept here? Free metal should be more reactive. You should not forget this concept. This is the concept. Free metal should be more reactive. Then only the reaction happens. Then only displacement reaction happens. Or takes place. Clear, students? So this point is very important concept. Clear, students? Okay. So this type of reactions may be called as single displacement reactions. Clear? Because only one compound is there, another is free metal. So it is a single displacement reactions. Another is double displacement reaction. So next one is double displacement. The name itself you can easily identify what happens. That means two displacement takes place. Okay, students, here two types of reactions are there. In double displacement, two types are there. So I will discuss it later. First, definition. What is the definition here? So definition for this reaction is, so first representation, see students, AB plus CD. Okay, it gives CB plus AD. This is why it is like this. So see here, this is positive charge, negative charge. This is positive charge, negative charge. Positive and negative will combine. So here this is positive and this is negative, CB. See students, plus minus, and A is plus, D is negative. See, two different products, not the same product. Product is different. Here AB, here CB, here CD, here AD. So it is different products. Clear, students? This is the general representation of double displacement reaction. Sometimes this representation also they may ask. Okay, what is the definition for this reaction? So here definition is, two or more compounds. Okay, students, two or more compounds react by, these are key points, students, by exchanging ions or radicals. The ions may be called as radicals to form two or more products or compounds in that one of the product, it is very key point, students, one of the product is an insoluble salt and forms precipitate. It is a very key point for the definition. Clear? So what are the key points in this reaction, students? See, two or more compounds exchanging ions to form two or more products. One of the product is insoluble and forms precipitate. These are the key points for this reaction. For definition, clear, students? Okay, here two types are there. Two types of double displacement reactions are there. They may ask. So what are the two types of reactions? One is precipitation reaction. One reaction is precipitation. Another reaction is neutralization. So two types of displacement reactions, double displacement reactions. Clear, students? Okay. So first we will discuss. So here double displacement reaction means exchange of ions takes place and new compounds are formed. So this is the definition for precipitation reaction, students. Why? It forms a precipitate and one is insoluble salt. So this is the definition for precipitate reaction. Clear, students? So in double displacement reaction, what happens? Exchange of ions between two compounds. So see here. Here I am writing exchange of ions between two compounds. In two compounds, exchanging takes place. Okay, students, this is the definition. So mostly they are asking definitions for precipitation and neutralization reaction, not for double displacement reactions. Okay. So precipitation reaction means what? One of the product is insoluble, which forms precipitate. So example for this reactions. See, students, best example or most repeatedly example is barium chloride. See, example, barium chloride plus sodium sulfate. When these two reacts, what happens? Here barium chloride in aqueous, that means it dissolved in water, and sodium sulfate also dissolved in water. Only in aqueous solution this reaction takes place. Aqueous means dissolved in water. Now what happened? Exchange of ions. See, this is positive charge, SO4 is negative, so Ba and SO4. See here, Ba is plus, Cl is minus, Na is plus, SO4 is minus. So exchange of ions. See, this one reacts with this and this one reacts with this. Clear? So what is the product now? BaSO4 plus NaCl. Okay, students, how many sodium, how many chlorine? 2, 2. So 2 NaCl. Here important thing is this barium sulfate is a solid, that is precipitate, and this is aqueous solution, that is dissolved in water. So this barium sulfate is insoluble. So here you have to mention barium sulfate is an insoluble salt which is a precipitate. Okay, and color of the salt is white precipitate. Okay, it is white in color. These are key points. Clear, students? This barium sulfate which is formed. How to mention the symbol of precipitate? It is also very important, students. You have to mention the symbol of precipitate in downward symbol. Downward symbol you have to mention, this is for precipitate. Clear? One more example for this reaction. Okay, students. Next, potassium iodide with lead nitrate. reacts means what happens. These are aqueous solutions only. In aqueous form only this reaction takes place. This is also aqueous. What happens? This is plus, this is minus, plus minus. That means potassium reacts with NO3. So it forms, here 2 nitrate are there, right? So 2 KNO3 plus PbI2. This is the product, students. Here this is aqueous solution, that is which is dissolved in water, and this is the solid. Clear, students? So you have to mention downward symbol. This is the precipitate. Clear, students? Okay. Here color of Ki is white in color, students. You should represent that also. See here, Ki is white in color, but PbI2 is yellow color. Mention this also. It is very important. Color is very important in this type of reactions. Clear, students? These two are frequently asked examples for precipitation reactions. Next, neutralization reaction. So next one is neutralization. So neutralization means it going to become neutral. So here best one is, this is the concept, students. When acid plus base gives salt plus water. This is the concept of neutralization. Here acid dissolved in water, so it is aqueous. Okay, aqueous solution of acid and aqueous solution of base. It forms salt and water. So this is the general representation of neutralization reaction, students. Okay, an example for these types of reactions. Now HCl reacts with NaOH. It gives what? Here also same thing, students, double displacement. Why means, see here, neutralization reaction also is a type of double displacement. That means here H plus Cl minus, right? Here Na plus OH minus. Now what happens? Exchange of ions takes place. See here, okay, H and OH gives water, and Na and Cl combined means it gives NaCl. So exchange of water takes place. So exchange of ions takes place. In this thing, here you have to mention aqueous. Without that, they will not provide marks. Everywhere you have to mention the physical state. This is also aqueous because it is dissolved in water, and water state is liquid. Clear, students? It is the best example for neutralization reactions. Next, important concept. So this concept, I'm going to explain two concepts, that is oxidation and reduction. This is not only helpful in your class grade 10, it is very useful for your higher studies, that is grade 11 and 12, as well as in IITs also. So important concept, oxidation and reduction. Oxidation reaction and reduction reaction. Okay, students, here definition for oxidation means substance which gains oxygen. Okay, oxidation means gains oxygen, that is oxidation, or which removes hydrogen atom, that is also oxidation. See, gain oxygen atom or removes hydrogen atom, this is known as oxidation reaction. Okay, gains means addition. Okay, students, it is addition of oxygen. Clear, students? It is very important definition. Okay, reduction means what? Next, reduction. Next one is reduction. See students, oxidation means gain oxygen atom or addition of oxygen atom. Here another definition is remove hydrogen atom, and reduction is just opposite to oxidation. See here, gains or addition of hydrogen atom or removal of oxygen atom. Clear students, this is the definition. Gains hydrogen or removes oxygen atom. Okay. One more thing is the agent. Okay. See, I am giving one clue. Oxidation means the agent is opposite, that is reducing agent. This substance acts as a reducing agent. Oxidation means the substance acts as a reducing agent. Substance acts as reducing agent. It is very important, student. Agent means something in between, right, which provides something to someone. So here the agent is a substance. Okay, why it is reducing agent? Because it's giving oxygen to another atom. Clear students? So that is reducing agent. Next, for reduction, the substance act as a oxidizing agent. So here simple clue I am giving. Oxidation reaction means addition of oxygen. The agent is reducing agent, opposite. That means the substance gives oxygen or gains oxygen. Substance acts as oxidizing agent. Okay students, so clear? So simple trick I am giving. Oxidation, this sun means agent is opposite. Reduction, shun. So reduction, reducing takes place. Reduction takes place means agent is opposite, oxidizing agent. Okay. See, now I am explain with examples. See now, best example. So first, copper plus oxygen. It forms copper oxide. Here 2 oxygen, so we have to balance 2, 2. Okay students, so here copper is a metal. There is no oxygen here, but in product it has oxygen. That means this copper is oxidized to copper oxide. Clear students? This, so here brown color copper powder, when reacts with oxygen it forms copper oxide, which is black in color. It is very important. The color is black. Color of copper oxide is black. It is brown powder, reddish brown powder. Clear students? These colors are clue for this reactions. So what is product formed here? Copper oxide. Okay. Next, one more example. When copper oxide reacts with hydrogen, it forms copper plus water. Okay students, here you have to find out which is oxidized, which is reduced. Okay, see here. So first, here copper, here copper. So consider these two. Okay, and here hydrogen, here hydrogen. Take. So first compare reactant and product. See here, oxygen is here, there is no oxygen. So oxygen is removed, right? So in which reaction oxygen is removed? In reduction, removal of oxygen. That means CuO is reduced. Clear students? So the reaction is, here what? Removal of oxygen means reaction is reduction. Okay, clear students? And compare H2 and H2O. What is difference here? In product, oxygen is added. You have to consider only products, not reactants. Okay, so oxygen is added in product side. So here Addition of oxygen means oxidation. Clear, students? So removal of oxygen is reduction. Addition of oxygen is oxidation. Clear, students? Okay. Here now agent. What I said, reduction means it is oxidizing agent. Oxidation means reducing agent, right? So directly you can write. So here CuO undergoes CuO undergoes reduction, hence CuO is a oxidizing agent. It's the opposite. Okay, students. Next, H2. Agent is always present in left hand side. See here, and H2. This H2 undergoes oxidation. Hence, H2 is what agent? Reducing agent. H2 is reducing agent. Clear, students? So this is the best example for oxidation and reduction reaction. But this one is example for redox reactions. What is reduction means? In a reaction, both oxidation and reduction takes place in a same manner. Together it takes place means it is redox reactions. So next one is redox. So next reaction is, which is very important, that is redox reaction. So what is redox reaction, students? In a reaction, both oxidation and reduction taking place simultaneously. This word is very important, students. Simultaneously. That reaction is known as redox reactions. So which point is important, students? Both oxidation reduction taking place simultaneously. Simultaneous means at a time the reaction takes place. So here one reactant is oxidized, other reactant is reduced. That also you have to mention. So one reactant is oxidized and other is reduced. So these are key points for the definition, students. Okay. Now examples. See, ZnO plus C gives what? Zn plus CO. So this is example for redox reaction, students. How it is example? See here, compare zinc here, carbon here, carbon here. Okay. So now see, here oxygen is there, here no oxygen. So removal of oxygen means what? Reduction. Removal of oxygen means reduction. So comparing with ZnO, no oxygen atom. So it is reduction, right? Clear, students? Next, compare here. Here see, here O. Addition of oxygen. Here oxygen added. So here what reaction? Oxidation. Simply with one atom you can easily explain. With oxygen, if you take oxygen, addition of oxygen means oxygen, oxidation, reduction of removal of oxygen means reduction. Like that in terms of hydrogen, addition of hydrogen, reduction, removal of hydrogen, oxidation. Students, if you are thorough in one atom, you can easily find out. So see here, so now I am writing here ZnO to zinc. What happened here? It is oxidation. ZnO to zinc is reduction, right? And which is the oxidizing agent, students? Here reduction reaction takes place. So the agent is opposite. Agent is substance, not the product. So here ZnO is a oxidizing agent. So agent is always a substance, that is reactant. This is a key point here. Agent is present in reactant side. You should not consider products. Okay, students. Next, C2CO, addition of oxygen. So it is oxidation. So oxidation means what type of agent it is? Reducing agent. What I said, the agent present in reactant side always, that means C. So here carbon is a reducing agent. Clear, students? And one more example. For one example I am clearly explaining. Next you can directly find out. So next, SO2 plus 2H2S. It gives 2H2O plus 3 sulfur. Clear, students? This is the equation. Now we have to compare reactant side and product side. Where is here sulfur? Here sulfur. So take this. Okay. So now here oxygen is there. Here no oxygen. So no oxygen means what it is? Reduction. No oxygen atom. So it is reduction. Okay, students. Next, consider this and this. See, here what happens? Here H2, here H2O. Oxygen is added. Oxygen added means it is oxidation. Added oxygen atom. So it is oxidation. Now tell me, SO2 is what type of agent? Reduction undergoing means it is oxidizing agent. So SO2 is oxidizing agent and H2S is reducing agent. See, SO2 undergoes reduction, so it is oxidizing agent. This one you can tell other terms also. Oxidizing agent means it gives oxygen to another compound, itself reduced. Clear, students? Next, this one is reducing agent. So this one, it reduces another compound, another metal, that is sulfur, itself oxidize water. Clear? Okay, so these are very important concepts, students. This oxidation and reduction. Based on that, many questions they may ask. It is a very important topic in this chemical reactions and equations topic. So don't miss that or don't omit this topic. If you are not thorough, practice it many times. So it will be easy for you. I am giving tricks also here. So follow the tricks. So it will be very useful to you. So once again I am recalling. So displacement means what, students? So one free metal displaces another compound metal. Clear? One free metal going to occupy in compound and another free metal you are getting. Double displacement reaction means both compounds are exchanging and forms a new compound. In the two types are there, precipitation and neutralization. Precipitation means precipitate will form. Neutralization means acid base reaction, students. Next, oxidation and reduction. Oxidation means addition of oxygen or removal of hydrogen. Reduction means addition of hydrogen, removal of oxygen. And the agent is opposite, students. No need to consider any definition, students. Only this trick you can follow. Oxidation means the agent is opposite, reducing agent. Reduction means agent is opposite, oxidizing agent. It will be, but here one thing you should remember, the agent is reactant, not a product. Clear, students? If you follow this, then redox reaction is very easy for you. If you like this video, please click on like button, share this video with your friends and subscribe to my channel. Don't forget to subscribe. Otherwise, you will not get notifications immediately. So thank you for watching. If you have any suggestions, please mention in comment box. Please give your comments. Thank you.